Now students, in last second lecture we saw three connectors, that is and, second or and third not. Now the remaining two connectors are if dash dash then, if not if. Look at how can we use for forming the compound statement and for getting the truth table. Look at, we are discussing about fourth one. Fourth we are taking, that is said to be conditional. Now look at conditional. Conditional. If two atomic statements are connect with a connective if dash dash then such obtained statement is called compound statement. In symbolic form, if P and Q are two atomic statements and they are connected with the connective if then in symbolic form we write it as P conditional Q, and we read it as if P then Q, or if P then Q. Instead of this we tell P conditional Q. This symbol is noted by conditional, P conditional Q. Now we are taking the practical example of it, the same process. We are taking two atomic statement P and Q. Look at how. Let P such that 2 plus 1 is equal to 3. Q such that 4 minus 1 is equal to 3. These are the two atomic statements. We are going to join this two atomic statement by connecting them. Then P conditional Q can be written as P conditional Q is equal to, or it can be written as, it is symbolic form. In verbal form we can write it as if 2 plus 1 equal to 3, then 4 minus 1 equal to 3. Now look at how it is. If 2 plus 1 is equal to 3, then 4 minus 1 is equal to 3. If 2 plus 1 equal to 3, then 4 minus 1 is equal to 3. It becomes a conditional. Now truth table for conditional. Truth table. For conditional. Here we are writing P, Q, then conditional P, conditional Q. Look at how to fulfill this truth table for conditional. The same process here. We are using T, F, TF. Same. These two columns are same. As usual we are using. Now we are changing the last column only. TT becomes T, TF becomes F, FT becomes T, FF becomes T. Now look at the truth table. Look at the truth table. TT becomes T, TF becomes F, FT becomes T, FF becomes T. Means the first part before this means the part which follows if is called antecedent, and the part which follows then it is called consequent. Means P is said to be antecedent and Q is called consequent. And we join them this arrow, then the result is this. When both the statement PQ are true, then the result is true. If both the statement P and Q are false, then it is also true. If first is false, second is true, its result is true. If first is true, second is false, result is false. Means in only one case the result coming false. And that case is P is T, Q is F, result is F. And it is said to be truth table for the conditional. And now last connector we are using, that is biconditional. That is biconditional. Biconditional. introducing here biconditional. Okay. Now that if two atomic statement P and Q are connect with a connective, if and only if and only if and only if two atomic statement P and Q are connect with a connective if and only if, then such obtained compound statement is called biconditional. In symbolic form, if P and Q are the two atomic statement and they are connected with if and only if, then symbolically it can be written as P biconditional Q. P biconditional Q. Particular example we are taking. Let P such that Ram is a good boy. Ram is a good boy. Q says that Ram is intelligent. Ram is intelligent. P says that Ram is a good boy. Q says that Ram is intelligent. Then the symbolic form is P biconditional Q. We read it as P biconditional Q or P if and only Q. In verbal form it can be written as is equal to Ram is a good boy. Ram is a good boy. If and only if and only if he is intelligent. He is intelligent. And now it's biconditional symbolic form, it's biconditional verbal form. Now I want to write its truth table. As before we saw, how can we write a truth table for conjunction, disjunction, negation, conditional. Now we are writing truth table for biconditional. P Q P biconditional T T F F alternate TF T F T F. These two columns are same. As earlier I told you this thing. P biconditional Q. TT becomes T. TF becomes F. FT becomes F. FF becomes T. Now look at the truth table. Look at the truth table. Okay. Means when both P and Q are true, then the result is true. When both P and Q are F, the result is T. Otherwise, the result is F. And now we consider all these things as a formula for solving the problems related to mathematical logic. Now we are coming to the next point. These are the 5 connectives and or not, if that then, if and only if. And how can we represent them? How can we write the compound statement in verbal form or in symbolic form? Now we see how to construct a truth table or how to write the given information in symbolic form to the verbal form. First I want to take the example how to write symbolic form into verbal form by using all the 5 connectives in a single question. Look at what is in these things. Now first I have to remove these things. Now look at we are taking example such that all the 5 connectives can be used in symbolic form as well as verbal form. For that, take in the first question. Let P such that the sum of angles of triangle is 180. The sum of all angles of triangle is 180 degree. We are taking the first P. Q such that triangle contains three sides. Look at, and I want to use these two atomic statement in different symbolic form. Then how to write in different symbolic form as well as in verbal form. The first part of it, P conjunction Q. Second part of it, P disjunction Q. Third part of it, negation P, conjunction negation Q. Fourth part, negation P, disjunction negation Q. Fifth part, P conditional Q. Sixth part, negation P, conditional negation Q. Negation Q. Seventh part, negation P, biconditional negation Q. Now look at how to write all this symbolic form into verbal form. We are given by first. Look at what about P conjunction Q. Already mentioned what is P, what is Q. P such that the sum of the angles of a triangle is 180. Q such that triangle contains three sides. I want to write some answer in verbal form as they are given in symbolic form. For that, first part we are taking P conjunction Q. Now it can be written as, look at P, that is the sum of angles of triangle is 180 degree. And why so? Because we are using conjunction. And it contains, and the triangle contains, and the triangle contains three sides. Okay. Now second, P disjunction Q. What they are saying? P disjunction Q. We have to write or means, but we will explain this one by one. The sum of the angles of a triangle is 180 degree, or triangle contains three sides. Okay. The sum of angles of triangle is 180 degree. In place of and we are going to put or. The triangle contains three sides. Okay. Now first and second example. Why we are using or and? Because we have disjunction. Now third part. Now we are able to write in verbal form. Now look at it. How to write the third answer. Negation P means the negation of it. Negation Q means the negation of this. Means the sum of angles of a triangle is not 180 degree, and triangle does not contain three sides. Okay. Now look at once repeating this thing for the third example. It can be written as the sum of the angles of a triangle is not 180 degree, and why is that? Because we are using conjunction, and triangle does not contain three sides. Now fourth, we are talking about the symbolic form of this fourth. It is given negation P, disjunction negation Q, and we have to write its verbal form. इसका verbal form लिखना है, language form लिखना है. तो language form के लिए the sum of the angles of a triangle is not 180 degree, not Q की negation है, or triangle does not contain three sides, not Q की negation है. Now we are coming to the big part. What can we write in place of P conditional Q? We have P already, we have Q already. It can be, if the sum of angles of a triangle is 180 degree, then it contains three sides. We are using phrase if then. If before P, then after P. Means if the sum, the answer of it, the answer we are writing of the fifth one. If the sum of the angles of a triangle is 180 degree, then it contains 3 sides. Now we are on 6th one. We are on 6th one. What about negation P, conditional negation P? Negation P. If the sum of the angles of a triangle is not 180 degree, why so not? We are using negation. If the sum of the angles of a triangle is not 180 degree, then it does not contain 3 sides. Why so? Because negation is there. Now we are using last one, 7th one, that is in symbolic form. I want to write it into verbal form. For that, look at the symbolic form, means by condition is given. Instead of it, we use if and only if. Means it can be written as the sum of the angles of a triangle is not 180 degree. If and only if, look at, we are putting if and only in between. If and only if triangle does not contain 3 sides. Why so does not? Because negation is there. Okay. Now repeating this thing. 7th one, I want to repeat this. The sum of the angles of a triangle is not 180 degree if and only if it does not contain 3 sides. And that's the part. Or that's why we can find the verbal form from the given symbolic form. Or sometimes they can give such type of verbal form and we have to write in symbolic form. That is vice versa. Now, I want to take another one example related to it for finding the verbal form from the given symbolic form statements. We are changing. Okay, I want to change this question as second example taking. Second example we are taking. Okay. Let P such that. Let P such that 2 plus 5 is equal to 7. Q such that 5 minus 1 is equal to 4. Is equal to 4. And I want to write the following symbolic form into verbal form. For that, number first, negation P, conjunction negation P. Now second, P, disjunction Q. Third, P, conditional Q. Fourth, negation P, conditional negation Q. I want to write all these things into verbal form by using the above atomic statement P and Q. Now look at it. First we are writing negation P, conjunction negation Q. No. Means negation for not. So we can write it as 2 plus 5 is not equal to 7 and why we use in place of conjunction and negation Q, and that is 5 minus 1 not equal to 4. Now look at it. We are writing the statement in numerical way. That's why should not put here not the symbol this way not in mathematics. Then it is 2 plus 5 not equal to 7 and 5 minus 1 not equal to 4. We complete our first part. Now we are on the second part. That means we have to write its verbal form P disjunction Q. That can be written as 2 plus 5, that is P disjunction Q. 2 plus 5 is equal to 7 or 5 minus 1 is equal to 4. And now it's a verbal form of the symbolic form P disjunction Q. Now what about P conditional Q? As we know, this symbol is used for if dash dash then it can be written as if, look at P conditional Q writing. P conditional Q writing is equal to if 2 plus 5 is equal to 7. If 2 plus 5 is equal to 7, then 5 minus 1 is equal to 4. And now we complete this condition. Okay, look at if and the part which follows it is called antecedent the part which follows that is called consequent. If 2 plus 5 equal to 7, then 5 minus 1 equal to 4. It is the symbolic form of the third one. Now what about fourth? Writing down side. Fourth one. Negation P. Negation P. Conditional negation. Now look at conditional here. But both the sides they are putting the symbol, not negation. It means it can be written as is equal to 2 plus 5, that is if. We are going to use if here. Okay, why? So because condition is there. If 2 plus 5 not equal to 7, why not equal to? Because negation is given. If 2 plus 5 not equal to 7, then 5 minus 1 not equal to 4. Look at it. Then 5 minus 1 not equal to. Why so not? Because negation is given. If then, in this way, we can find the symbolic form into verbal form or verbal form into symbolic form. Whatever they are discussing in the question, by using the concept, easily we remember, we learn about 5 connectives, and they are most important, and or not if that then if you are not if. Now, after completing this part, we are coming to the next part. We know how to write the verbal form into symbolic form or symbolic form into verbal form. Now taking next concept of it, that is how to construct the truth table from the given statement pattern. Look at it. Yes, we are looking for the next thing, that is how to construct truth table from the given statement pattern. First, we try to understand what is the statement pattern. What is the statement pattern? If 2 or more atomic statements are connected with 1 or more connectives, then such obtained statement is called statement pattern. For example, look at, for example of statement pattern. First, negation P, conjunction Q. Number second, P, conjunction Q bracket close, disjunction P conditional Q. These are the statement pattern. Why so? Because 2 or more atomic statements are connected with 1 or more connectives, then such obtained statement is called statement pattern. Now example are mentioning here. Look at how many atomic statements are there? 2. What are they? P and Q. How many connectives are using? 2. What are they? Negation and conjunction. Here, how many atomic statements are there? 2. What are they? P and Q. They are repeated, that is different thing. But we consider P as P only, Q is only. Okay. Now how many connectives are using? 3. What are they? Conjunction, disjunction, conditional. And now I am telling you, how can you construct the truth table? How can you construct a truth table from this statement pattern? Now look at the first one. We are forming or we are constructing or we are preparing the truth table for this statement pattern. Now we have P, yes. We have Q, yes. We need negation P, yes. No. We need negation Q, no. Why so? Because in this statement there is no negation Q. Then last, negation P and Q. Last, complete. For forming this truth table or statement pattern, last will be this way. Now first to check how many rows and how many columns are possible for forming a truth table from the given statement pattern. For that, look at it. First to check how many atomic statements are there. They are said to be component. There are 2. What are they? P and Q. Negation is the complement of 2. We are not discussing this thing. We are discussing about the main component or main atomic statement. What are the main atomic statement? 2. P and Q. Then for P and Q, as you know, the formula for finding the number of rows equal to 2 raised to the power n. N means number of component. Means number of rows can be calculated by number of rows is equal to 2 raised to the power n. N means number of component or number of atomic statement. So here P and Q are the two atomic statement. That's why 2 raised to the power 2. That become 4. It means that there should be 4 rows. 1, 2, 3, 4. Now columns. Number of how can you find number of columns? How can you find number of columns? Number of columns equal to formula is n plus n. And number of component and number of connectives. Look at n is 2 here because P and Q there are only 2 atomic statement. How many connectives? 2. Ignition first and conjunction 2. 2 plus 2. That becomes 4. Means we have 4 rows and 4 columns. Look at first fill T, F, F. It is fixed. Q it is fixed. T, F, T, F. These two things are fixed. Negation P opposite of P. इस P का opposite क्या लिखेंगे? F, F, T, T. Negation P का Q के साथ conjunction लिखेंगे. तो from the conjunction table, truth table मैं आपको पढ़ा चुका हूँ. ट्रूथ टेबल के अंदर एक नेगेशन भी P का काम करेगा, ये Q का काम करेगा. एंड वी टेक द टेबल ऑफ फर्स्ट दैट इज कंजंक्शन. कंजंक्शन टेबल में लिखेंगे तो Ft1 becomes F, Ff becomes F, Tt becomes T, Tf becomes F. And look at how many rows are there? 4. 1, 2, 3, 4. How many columns are there? 4. Look at 1, 2, 3, 4. And it's our truth table. It's our truth table in the given state of matter, that is negation P conjunction. Main thing is that first you have to know how many number of rows and number of columns for constructing the truth table. That formula is 2 raised to the power n. N is denoted by number of components. There are 2 components P and Q. That's why 2 raised to the power 2, that becomes 4. Here number of columns. How to find number of columns? N plus n, where n number of components and number of connectives. So how many number of rows and columns? Look at n, we already have 2. M number of connections 2. What are they? Negation and conjunction. 2 plus 2, that become 4. That's why we have 4 rows. 1, 2, 3, 4. 4 columns. First, second, third, 4. Look at one thing. Rows are start from top to bottom. Top to bottom. This way. First row, second row, third row, fourth row. Columns start from left to right. That is first column, second column, third column, fourth column. And in this way, we obtain or we construct or we prepare the truth table from the given statement pattern. Similarly, we can find this truth table. P conjunction Q, bracket close, disjunction P conditional Q. For that, first we have to check how many atomic statements are there? 2. What are they? P and Q. Means number of component n equal to 2. Means number of rows here 2 raised to the power 2, that is 4 again. Okay. In this question, number of rows 4. Now what about number of columns? Look at n plus n. N means number of components. M means number of connectives. How many connectives are there? Look at it. 1, 2, 3. Means number of columns is n is 2, m is 3. 2 plus 3, total is 5. Means for constructing the truth table of the second part, we have 4 rows and 5 columns. And by using this concept, we can form this truth table. And now, up to here, we know how can we use the connectives in mathematical logic. There are 5 connectives repeating these things, and or not, if then, if and only if. By using these connectives, we know in last, including this lecture, 2 lectures, how can you write or use connectives for writing in symbolic form, or how can you write them into verbal form. Now, other thing, how can we construct the truth table? How can we construct the truth table? For that, first we have to find number of rows, then number of columns. For finding the number of rows, we have the formula 2 raised to the power n, and denotes the number of component or atomic statements, and n number of connectives. 2 raised to the power n is said to be number of rows. N plus n is called as number of columns. And in this way, we can construct the truth table from the given statement pattern. And these things are very important. Okay. Further that, the terminology arises, that is tautology, contradiction, logical equivalent. Before that, we have to learn this 5 truth table properly, such a way that you can solve the questions related to it in mathematical logic. If you are not knowing properly this 5 truth table, mean what the result is, then we are not able to construct a truth table or write the correct answer from the given question. Now we complete up to here how to form the statement pattern, and I hope you know all these things properly. And for further third lecture, first you have to know all this concept properly, then only we are able to understand the third lecture and the third concept also. Thank you very much for watching.